In this video, I'm going to review finding the end behavior of a polynomial. We'll look at both polynomials in factored form and in standard form and see what are the clues, how can I figure out what the ends of the graph are going to do. It all depends on the leading term. The whole idea of what happens when x gets big is controlled from that highest exponent. Because when you take a big number to a power, that's going to overpower multiplication, addition, subtraction, division. Everything else going on is going to get overwhelmed by that high number to a large power. So we're looking at the leading term. Now, a quick review. This is the screen we had, the notes we took in class. This is what we're going to base everything on. Just going to add a few notations on here. First thing, we're splitting what's happening. We have two different types of end behavior. And on these sides, they both go in the same direction. Both ends are going the same way. This end is going up. The left end is going up. Right end is going down. Left end is going down. They're both going in the same direction. And that's going to happen if you have an even degree. Makes sense. You take a positive number to a high exponent, it's going to get positive. But when you take a negative number to a even degree, it's going to turn positive as well. So that's going to be both positive. Now, in order to make this go negative, we look at the leading coefficient. The number we're multiplying that leading term by. If it's positive, both ends are going to go up. If it's negative, both ends are going to go down. But if it's an even degree, and the degree is, again, the highest exponent in standard form, then it's going to behave this way. Now, again, let's talk about the odd. If it's odd, then the ends are going to go opposite directions. So in here, on the right it goes up, on the left it goes down. Here on the right it goes down, on the left it goes up. They go in opposite directions. And that's going to have when we have an odd degree. Because if you take a positive number to a power, it stays an odd power, it stays positive. A negative number to an odd power, it stays negative. The only way to switch that is by multiplying by a negative. So again, we look at that leading coefficient, positive or negative. Another thing that might help you to notice or look at this. That's not the one I want. Let's go with this one. Okay. You notice when we're positive, this goes up. We're positive on the right, it goes up. On the negative, on the right, it goes down. Negative on the right, it goes down. That positive negative is going to say what's going to happen as x increases. As x increases, if it's multiplied by a positive number, it's positive. Multiplied by a negative number, it's negative. Multiplied by a positive number, it's positive. A negative number, it's negative. Now, the difference then for the left-hand side is even, they're the same way. Odd, they're opposite directions. There's lots of ways we can describe it. We described it by using just little pictures to show us what's going down. The words we're going to use, that's why I'm coming to this slide, as x increases, as x decreases. Y increases, y decreases. So when we're looking at this, let's go over here. Here, x is increasing when we're going in this direction. When we're going in this way, x is decreasing. X-axis goes left and right. Y goes up and down. So if it's going up, Y increases. If it goes down, Y decreases. So here, as X is increasing as you're going to the right, Y is decreasing. As X increases, Y decreases. As X is decreasing, we're going to the left, Y is increasing. Y is going up. This is one of these four choices is going to be your answer every time you are asked an end behavior question about polynomials. Every polynomial will have one of these four. And it all depends on the degree, even, odd. It depends on the leading coefficient, positive or negative. So the real trick to doing end behavior is figuring out what is the leading term. Our favorite is standard form. If I said f of x equals 3x to the fifth minus 7x squared plus 11, my leading term is going to be the first term. That's the idea of standard form. The leading term, the first term is going to be the highest degree. So this is degree 5. So it's odd. The leading coefficient is 3. So that's positive. So we're odd, opposite directions. Positive means we're going up. So it's going to be going like this. So as x increases, y increases. As x decreases, y decreases. You don't remember those terms? Come back to this. Have this written down so you can refer to it. One of these four things is what it's always going to be. Let's look at another problem. Let's go g of x equals 3x to the fifth minus 7x to the eighth plus 11x to the third. Now this is written as a sum or difference of terms, but it's not in standard form because the highest exponent is not up in front. But this is still, when I want the leading term, I'm looking for that highest exponent. So this is a degree 8. So this is even. And this has a leading coefficient of -7. So it's negative. So both ends are going to go the same direction, but they're going to go negative. They're going to go down. So this is your end behavior. As x gets bigger, y gets smaller. As x gets bigger, or x gets smaller, y gets smaller. When they're written out as terms, look for that highest exponent. Hopefully you're in standard form, so it's the first one. But it's not always, so keep an eye out for that. When you are in factored form, we have to do a little bit more work. H of x equals 3, x plus 7, x minus 3, x plus 9, x plus 1. So its nicest case with factored form is each factor is a 1x plus or minus a number. Then when we come along, we can say I got 4 factors. We're going to be 4th degree. I got a 3 out front, so the leading coefficient is 3. But this only works, well, this is going to be even positive. Both go in the same direction. They're both going up. But we can only do it this quick if this is a 1x, a 1x, a 1x, a 1x. We got anything else going on here, we got to be careful. Just like with standard form, if it's in, strictly speaking, factored form, which is your leading coefficient times all of your factors being x plus or minus a number, we can fall back on that, and it's just that easy. However, if it's factored, but not exactly in this form, so let's go p of x. Let's go a negative 2 times 3x minus 5 times 2x squared plus 7 times x plus 3 about times 7 minus x. So we're still in a factored form. We're not strictly speaking factored form because these are not all factors of x plus or minus a number. So what we can do to find the leading term is multiply all the leading terms. So we got a 2 here, 3x here, 2x squared there, 1x here. Now here, this is the leading term on this last factor because it's the highest exponent. So we would take negative 2 times 3x times 2x squared times 1x times a negative 1x. That's going to give me negative 2 times 3 is negative 6 times 2 is negative 12 times 1 is negative 12 times a negative 1 is positive 12. We got x times x squared is x to the third, x to the fourth, x to the fifth. 12x to the fifth. So now once we have that leading term, we can come back and say, oh, I gotta go back here. This is going to be even, or this is going to be odd, degree 5, and it's going to be positive. So my end behavior is going to be as x increases, y increases, as x decreases, y decreases. Again, your main key to end behavior is it all depends on that leading coefficient. So make sure you can find the leading coefficient, that leading term. You can find that leading term, you can find the degree and the positive, negative.